All right, everybody, it's 11 o'clock, so we're going to go ahead and get started with today's Clean Coast, Texas Lunch and Learn. We're just going to go over another round of housekeeping for today's presentation if you're just now joining. So please keep yourself on mute throughout the meeting to help with background noise and feedback. If you want to keep your video on or off during the presentation, that's completely up to you. We're going to be using the chat function today in Zoom to submit any questions or comments for Dr. Olmstead during her presentation. So if you have any questions as she's giving her presentation, please go ahead and enter them into the chat, and there will be a facilitated Q&A after she's done presenting. And if you want to take a few seconds to go ahead and introduce yourself in the chat and your name and where you're from or who you're with, we would love to know who's all here. And without further ado, I'm going to pass it off to Jason Pinchback with the General Land Office to get us started.
Thank you, Allie. Good morning. My name is Jason Pinchback. I work at the Texas General Land Office in the Coastal Resources Division. We're excited today to present Clean Coast Texas Lunch and Learn Series workshop with the next installment today, focusing on economics of non-point source pollution. This is a topic we're very excited to explore. And as you all may know, as also coastal practitioners, it's difficult to find good information on the topic. One thing we're doing here with the Lunch and Learn series is bringing information that sometimes is only accessible if you read a complex scientific study or you attend a workshop or conference specific on the topic. So one of the things we're doing here is to break down some of those barriers and to allow for this information to be more accessible and easily used, with the idea of working with coastal communities and following up with some of this action, with some of this information with actual action on the ground to improve water quality and enhance the management of non-point source pollution. For more information, we'll post some links later on to the Clean Coast Texas workshop and how you can collaborate with us and potentially become a partner. Without any further ado, I would like to introduce Dr. Sheila Olmstead. She is a professor at the LBJ School of Public Affairs at the University of Texas at Austin. She's also a university fellow at Resources for the Future in Washington, D.C., and a senior fellow at the Property and Environmental Research Center in Bozeman, Montana. She is an environmental and resource economist with expertise in water pricing, water markets, and the environmental impacts of unconventional oil and gas development, water quality evaluation and regulation, the impact of flood risk on property markets, and market-based approaches to pollution control. I'd like to introduce Dr. Sheila Olmstead. Sheila?
Yes, thanks so much, Jason. I'm so happy to be here. I'm just going to go ahead and share my screen. Can everyone see my slides?
Yes, we can. And
super.
In your presentation mode, thank you.
Yep. All right, thanks so much. So I was asked to talk today about one particular type of water pollution, non-point source pollution, and the implications of that type of pollution for the Texas Gulf Coast. And I was so happy to do that because, as you'll see, it pairs very nicely with some of the research that is underway in my research group here at UT Austin. And I hope to actually extend some of what I've been doing to Texas, and I have a grant proposal in process to do that. So we'll talk about all of those things. Just, I'm sure there are many people on the call who knew a lot more about this than I do. I'm not a natural scientist. I'm a social scientist. I'm an economist by training. But just for those folks who might not be aware, non-point source pollution is pollution that's kind of coming from diffuse sources. So like agricultural and urban runoff, atmospheric deposition. So that'd be a case where, power plant emits nitrogen oxides, and then some of that nitrogen ends up in coastal waters or other waters within the state, as well as runoff from forests and mines. And for those of you who don't know, non-point source pollution from agricultural activities is now the primary source of impairment in US rivers and streams. That's been true for 10 years or more. And increasingly, right, is a challenge in estuaries and other kinds of water bodies as well. And while part of that, that kind of growth of NPS pollution as an important source of impairment in US waters comes from regulatory choices that we've made, right, in the United States, which is not atypical. Other countries in other regions of the world, developed countries and industrialized countries and so on, have made similar choices. But while point sources of water pollution, like a municipal sewage treatment plant or an industrial source, have been regulated in the United States under the Clean Water Act since 1972 and even earlier in some cases, Non-point sources are generally not, with some important exceptions, right? So some combined animal feeding operations, for example, on the agricultural side, may be regulated under the Clean Water Act. There are urban stormwater controls, right, that have been increasingly required over time. But there's still a lot of that kind of diffuse pollution that makes its way into waterways that is essentially unregulated under the Clean Water Act. And so partly for that reason, we see this kind of point sources kind of coming down in importance in terms of their contributions to impairing, right, the kind of capacity of waters to meet their designated uses in a regulatory context, which could be, as a source of drinking water, or, swimmable, boatable, fishable, and we'll talk about some of those designations in just a couple of minutes. So I'll focus on one particular type of non-point source pollution, which I'm going to call nutrient pollution. And that's kind of a catch-all term, right? So there are, a lot of nutrients like nitrogen, phosphorus, but also sediments and other things that run off of kind of urban land or agricultural land into waters that could be coastal waters or other receiving waters. And what happens is you have this sort of kind of nutrient over-enrichment, a flush of these additional nutrients. Not surprisingly, right, that nutrients is the right name for them. They cause, kind of plant growth. And so algae grow excessively in these waters that are affected by nutrient over-enrichment. And then those algae, as they die, they sink to the bottom, they decompose, and they use up oxygen in those waters. So one of the kind of primary problems and reasons that these waters become impaired for certain uses is that kind of loss of oxygen creates, conditions in which either some or all aquatic life can't be sustained, right? Then these are the kind of dead zones that we hear about, like the sort of annual summer, dead zone in the Gulf of Mexico that results from nutrients, running off all the way from kind of the upper Midwest in the United States down to the Gulf Coast. And this nutrient pollution is a major non-point source pollution challenge in US coastal waters. And so this is just identifying kind of all the places that have these kind of hypoxic conditions, these low oxygen conditions in North America. And what you can see is that it's for sure almost everywhere kind of on the Atlantic coast and the Gulf Coast in the United States, including the Texas coast. We have these conditions on a regular basis, especially in the summer, but it's increasingly seen on the West Coast as well, and particularly in the Pacific Northwest. So with respect to Texas in particular, I had some work that we did with co-authors a couple of years ago, showing that if you think about on the left-hand side is a set of graphs that shows us the kind of what water quality parameter among a set of 4 or 5 is the kind of key kind of parameter that's causing impairment of the water body in Texas. And this is just looking at, millions of observations of, sort of all across the state from 1970 through 2018. And what you see is that if we're looking at the kind of EPA, and state, kind of matching designated uses of water bodies, things like drinkable, right, sort of as a source of drinking water, swimmable, fishable, boatable, these thresholds have certain values of each of these water quality parameters that have to be achieved in order to meet that designation, right, for swimmability or for fishability, for example. And so what we're showing here is that, right, the kind of constraining parameter, the one that is causing the water not to meet that designated use of drinkability, swimmability, fishability, boatability, over time, what we see is that dissolved oxygen, total suspended solids, right, are kind of growing in their importance in that kind of the capacity to impair waters for meeting those kind of designated human uses in a regulatory setting. And on the right-hand side, what you can see is a sort of similar pattern. If we look at, we don't have national standards, kind of federal regulatory standards for chlorophyll A, which is, right, another kind of important indicator of nutrient pollution in waterways. But we do have in some states, including the state of Texas, for some water bodies, chlorophyll A standards. And what this graph is showing on the right is, again, kind of between 1970 and 2018, if we thought about applying that chlorophyll A standard all the way back to 1970, kind of what proportion of waters would have met the standard back in 1970. And you can see with that blue line that most of them, kind of between 80 and 90% of them would have met that standard, but we see this decrease over time, again, sort of indicating to us that nutrients and kind of nutrient pollution, especially from these non-point sources, is just an increasing challenge for the state in terms of the capacity to meet, right, the kind of the standard, for whatever designated use the water body is meant to meet. And that nutrient pollution creates economic damages, right? So, folks with a natural science background, right, you can kind of go through the chain of events in your mind of what happens within the aquatic system when, right, we have that nutrient over-enrichment. And I, as an economist, can also go through in my mind kind of what the resulting economic damages might be. And so there are lots of folks that have estimated this in different contexts. Marty Smith and his colleagues at Duke have, nice work showing, the impacts of that annual summer hypoxic zone in the Gulf of Mexico on shrimp, right? Sort of the commercial shrimping industry, which is a super important fishery as far as US fisheries go. And that work was published in the Proceedings of the National Academy of Sciences in 2017. There's also really interesting kind of recent work on the human health effects of harmful algal blooms. So not all of that algae, obviously, that sort of grows and dies and creates hypoxic conditions is in and of itself harmful to human health or aquatic health. But some are, right? There are some, important, types of algae that are, that create human health damages. And there's some interesting work on that. In a lake in Michigan, right? Benjamin Jones, who's an economist at the University of New Mexico, has showed that there's a causal impact of exposure of, sort of pregnant women to, harmful algal blooms in Gull Lake, Michigan on the incidence of low birth weight. So increasingly, we start to see these impacts on human health, which also have some very significant economic implications. And then there are other places around the country, like in Lake Erie, where, on a regular basis, we've seen things like water utilities that have to, sort of shut down their distribution systems because of harmful algal blooms in the source, in their drinking water source. So, and those kinds of incidents have costs as well. The focus of my work has been more on the next two bullets on recreational damages, right? So, it turns out, not surprisingly, that anglers and other aquatic recreators, kayakers, bird watchers, beachgoers, are sensitive to water quality at the locations where they recreate. And so there are plenty of studies over time showing that, right, people prefer to recreate, have a, sort of increased willingness to pay to take trips to, for example, go to the beach if the beach is cleaner than if it's dirtier. And so we can measure those, those changes in terms of recreational damages from water pollution as well. And then there are some of those also, those kind of damages, recreational damages, are incorporated in property values, right? Because if I moved to Galveston in part because I like to go to the beach and fish, but now water quality is diminished, well then, right, that can have this echo into the housing market in the city of Galveston as well. But those property value impacts, can extend to a much broader geographic area if, for example, lots of folks in Houston or even in Austin, right, like to recreate on the Texas coast, and right, there's this, impaired ability to do that because of water quality. So my work, and I'll talk about that more specifically in a few minutes, has looked at property value impacts in some places as well. And then increasingly, there's a focus on climate damages from this type of water pollution, from nutrient over-enrichment. And the big story there is that when you have in lakes in particular, this was this study by John Downing and myself and several others this year, when lakes, right, are eutrophic, they emit methane. Methane is a potent greenhouse gas. And so what we did in this paper is make an effort to kind of monetize the climate damages associated with that, and then look forward and think about, right, how large those effects are likely to be at a global scale going forward. So I'm just going to very briefly talk about those climate damages so you get a sense of kind of just that aspect of valuing the damages from water pollution. And then I'll switch to thinking about property values and recreational impacts, which are perhaps, kind of the most relevant to the Texas case and what I hope to be doing over the next couple of years. So on the climate damages side, Lake Erie has, a really severe problem with nutrient over-enrichment and eutrophication. On a global scale, methane emissions from eutrophic lakes have a climate impact that we estimate is about 20% that of fossil fuel, emissions from combustion of fossil fuels. And for Lake Erie in particular, if we sort of just take one specific example and we calculate those climate damages using estimates of the social cost of carbon, which is the sort of economists' kind of rule of thumb for what the damages are from 1 unit emissions of CO2, 1 ton of emissions of CO2 equivalent. We calculate those emissions for methane emissions from eutrophied Lake Erie as exceeding all of the other kind of monetized recreational damages from eutrophication in that region. So that includes fishing and beach attendance, right? Those are the two major things that have been studied in that area. Switching to the question of property value impacts, so a study that I published earlier this year in 2022 looks at what the impacts of long-term recovery from eutrophic conditions in Tampa Bay, Florida has done for property values in the region. Tampa recently has had like some decline in that water quality. We our study ends in 2018, so it's we can't tell kind of yet what happened after the kind of recent challenges with additional phosphorus and so on that they've experienced from some important spills. But from this recovery that occurred, from the 1970s through 2018, we looked just at the kind of end period of that, starting in 1998, when we're able to capture, kind of property transactions data starting in the mid 1990s. And we estimate that most of the property value impacts, which are actually quite large, and I'll show you some of those kind of monetary estimates in just a minute, are from these recreational benefits, right? So we had, a system that had originally been kind of a clear water, seagrass, kind of beautiful setting, and then had a period in the 70s, 80s, and early 90s that was, highly impaired from a nutrient over enrichment. So lots of mats of, macroalgae sitting on the top and getting stranded on seawalls at low tide, and, low seagrass, kind of growth, and those kinds of, kind of turbid conditions in the bay. And then, right, a period of recovery from the 1990s through 2014, 2018. And that had what we estimate to be very large impacts, positive impacts on property values in the region. And we show in our study that what you really need to do is incorporate, kind of these patterns of where people go, which, fishing sites they go to, for example, on a regular basis to really do a good job estimating the property value impacts. And what we show is that the benefits of that cleaning up very, very likely exceeded the cost. And I'll give you some sense of magnitude here. It's a little hard to read this. I apologize for the fuzzy numbers. But one thing I want you to have in your mind is that over this study period between 1998 and 2014, when we looked at Tampa Bay, regionally, a mix of public institutions, private donors, public-private entities, and so on, spent about $500 million, so about $500 million, on all kinds of different approaches to reducing nutrient runoff into the bay. So they spent about $500 billion. And our job was to think about what did they get back in terms of the property value impacts from those efforts. And we value it in several different ways. I won't get into the kind of the statistics of the study that we did, but I'm happy to take questions about that in the Q&A. And we estimate the benefits in two kind of classes of the ways that people kind of value water. One is just what we call the amenity benefit, which is, the water looks better, smells better, very close to your house, right? So these are the benefits that accrue from water quality improvements within, say, 2 to 3 kilometers of each home in the region. And then we also estimate as a separate matter, the recreational benefits. So what happened in, waters in the bay, on the bay, in the major rivers that are coming into kind of inland in Florida from the bay. And those, sort of estimate those separately, and then we add them up. They're different things, right, that people value differently. And so, what you're looking at basically is the kind of last row in these two tables right here is that kind of combined recreational and amenity benefit. The two different panels are from two very different ways of estimating them using these two different statistical approaches. And I would ask you to focus on this kind of last number that's in each of the tables, right? And there's quite a big difference using these two different approaches, but we would estimate benefits in the range of between $1 and $20 billion per year, whereas again, right, the kind of costs were about $500 million. So, right, looking at the benefits that we estimate again here in Tampa Bay, right, for this particular case of, recovery from eutrophic conditions, it looks like the benefits were worth the cost. And that, again, that's just looking at benefits to local property owners in terms of both the recreational opportunities that they had from better water quality and that kind of, things looking better, smelling better, and so on, close to your home. That doesn't count, benefits to tourists who, travel to Tampa Bay for fishing. It doesn't count benefits to, kind of aquatic life for which many people have, some demand or some willingness to pay. So it's a partial estimate, but even with that partial estimate, we can kind of get over the hump of justifying the costs, spent to achieve that water quality gain. And the last thing I would say is that with the methods that we used in that paper on Tampa Bay, we wrote a grant to the U.S. Environmental Protection Agency. They had a solicitation earlier this year on estimating water quality benefits. And we wrote a proposal that would do basically a similar kind of analysis on kind of what have been the recreational and property value impacts of water quality improvements or water quality, right? If water quality has gone down, what would be the converse of that? What would be the kind of cost of the water quality damage? For the Texas Gulf Coast, for Long Island Sound, and for Puget Sound. And so we've heard recently, I should say, I don't want to jinx myself. As I mentioned yesterday, I'm going to knock wood when I talk about it, but we believe that that proposal is going to be funded. So we're looking forward to getting started on some similar work for Texas, as well as the other two regions. Our current plan is to estimate the impacts of Texas coastal water quality, likely using either dissolved oxygen or chlorophyll A or both of those as the kind of key water quality parameters. And we want to estimate the impacts of those on recreational fishing using the Texas Coastal Creel Survey, as well as property values in the state. We would love to include other kind of recreational endpoints like beach visitation, wildlife watching, anything that folks track on kind of a broad enough spatial and intertemporal scale for it to be useful for us. So you should please let me know if you have ideas, right, for data that we could look at and see whether it might be suitable. And that's it. Yeah, I'm happy to take questions.
Thank you, Dr. Olmstead. Wow, that's what you just gave is going to take a while to soak in and steep, at least for my brain here. So thank you so much for that information. And just to remind folks who are listening in, if you have questions or comments, please feel free to include those in the chat box using the comment function, and we'll move through those here shortly. And so, Dr. Olmstead, as I was listening to you unpack some of this information, it becomes quickly obvious that we need hours, if not days, to really dive in to get more information about this. But one thing right off the bat is that in this community of practice with other folks working in coastal water quality issues, coastal natural resource issues, we sometimes do not have quick access or easy access to this type of information that you're sharing. When you talk about the benefits of the water quality of being good versus bad. And I was wondering, how can you make this information, or how could one make this information more accessible to those working in this field?
Yeah, it's a great question. I mean, right, it's always a good question for academics, right? Because that, what I would say is, there are some good, one place to start would be, kind of meta-analyses, right? That kind of take a whole bunch of studies and kind of put together, estimates of what have been the impacts of water quality, parameter X on, economic outcome Y. And some of those do exist. There are, kind of things like that out there that might be useful. I think conversations like this can be really helpful, right? And people reaching out with specific questions that they have about, well, in my particular context, we're interested in this question. Is that something, right, that could be, addressed in a quantitative kind of monetized way? And generally, folks, I certainly would give you an honest answer. I think most people would, but it's my field of environmental economics is a huge field. There are just tons and tons of people, right, that work on valuation and water quality. So yeah, I mean, I'm happy to take questions at any time, right? From folks who want to follow up by email too is fine.
Great. Well, thank you for that. And thinking about your study in Tampa Bay, and you had 3 different sections there where you broke down your evaluation on the amenity benefit and the recreational benefit. I'm curious, and I don't know if this was part of your study, but were any of these changes observed by the local community anecdotally or in actual hard values? Was there other comps that you're able to bring in?
Yeah, no, it's a great question. I mean, the statistician's answer would be, well, if they hadn't, then we wouldn't have seen the impact on housing prices, but that's not a very fair way of talking about it. I think one way to say that is I would be surprised if many homeowners, right, or kind of buyers and sellers consciously said, oh, the water quality at the beach is better, and thus I'm willing to pay more for, right, this home. It's more that, right, as Tampa Bay became a better place to recreate, a better place, right, there's these macroeconomic impacts, and you get more jobs and more growth, right, and then you have, right, this kind of natural impact on property values, just like what we're seeing in Central Texas, right, from people wanting to come here, right, and as a result, the property values getting higher. And what I would say is that this particular method, which is called the hedonic property method, really can't be used for something that would be, you can imagine a case where there's groundwater contamination, but it's very quiet, nobody knows, and right, there may be health impacts, but people are unaware. That would be not a great situation, right, in which to use this particular set of methods. But when we're talking about, surface water, these kind of charismatic water bodies like a Tampa Bay, or like, right, many of the bays that we have on the Gulf Coast in Texas, where you have lots and lots of contact recreation, and you have, right, people that are, quite aware, especially anglers, right, are highly sensitive to the catch rate and things like that, and word gets around. So, it's not surprising to me, right, that we do pick that up and we can detect that. But again, right, it's not so much, right, again, these are non-market goods. It's not, people are not going, right, to the grocery store to buy a better, higher dissolved oxygen, right? So it's a less conscious process, but yet we can still take advantage of the fact that we see the kind of footprint of that value in the property market, right, to estimate the demand for it.
Thank you for that. And what you just said, it reminded me of a little bit as we were chatting before this meeting here. You had something that I wrote down when you said it, is that there is a demand for clean water, and this demand leaves a footprint.
Yeah, and it actually is a big challenge for economists, right? These kind of non-market goods, but some of these methods go back. I mean, it's interesting. Historically, there's a man named Harold Hotelling who did many different things in his career. He was an economic statistician at UNC Chapel Hill, and the director of the National Park Service in 1938, 1940, wrote a letter saying, hey, I know, right, that the kind of these parks that I run have value, but every year I sit in front of the Congress and I have to justify my budget, and they tell me it's so costly, and I don't have a way, right, of quantifying the benefit side. And, he wrote to a set of smart folks and said, what should I do? And Harold Hotelling wrote a letter back, and he said, people spend a lot of time and money to get out to these parks, and you could exploit that, right, that kind of variation in those expenditures to try and understand, to try and estimate kind of a lower bound, right, on how much they value these places. And that gave birth to something called the travel cost method, or the kind of recreational demand modeling, which is an important piece still, right, of kind of our field's capacity to value, places like that. So it started a long time ago, but it's right, something that's developed a lot over the past many decades, and kind of continues to be an exciting way of thinking about these important places.
Fantastic. So I'm going to turn to our chat, and we'll start with some questions here. I'm going to combine one from Doug as well as Corey. And so Doug asks, what is the funding source for the coast-wide study?
Yeah, so this was the US EPA had a solicitation that was due back in January. It was a request for proposals on valuing water quality. And what they're looking to do, you can imagine there are many different contexts in which these methods are valuable. One is in regulatory settings, right? So if, for just as an example, right, EPA is still trying to work on how to deal with kind of changes in the Clean Water Act that happened under Obama, and then Trump, and then Biden, right? And the valuation that takes place in that process, right? So any major regulation in the United States, anything that's anticipated to cost $100 million or more per year to the US economy, has to undergo a rigorous benefit cost analysis. So that's one context in which these kinds of valuation estimates get used, which is that agencies estimate the cost of water quality, regulation, and then they have to estimate the benefits as well. And so we see a lot of these, that kind of work in those settings. We also see them a lot in litigation, right? So in the Deepwater Horizon case, or the Exxon Valdez spill, right, back in 1989, Deepwater Horizon being in 2010. In both of those cases, major studies were funded, right, to try and get a handle on what the damages were, right, from those spills, so that the state governments who were involved in suits and the federal government, right, which was involved in lawsuits, had an anchor for, how to think about, what they should be trying to obtain in litigation. So there are many different, in addition to just academics like me, right, who are sort of interested in, kind of trying to develop the methods further and do a better job and understand, how large those benefits are. So there's a lot of different settings in which they're used. And I think so, right? So EPA is very interested, right, in developing better methods from that, kind of regulatory perspective. But there are other agencies like NOAA, and others that tend to fund this kind of work as well.
Corey writes, great work and fingers crossed for your proposal. Does Texas routinely collect chlorophyll A data for assessments, and has it varied through time? You may not know, but others on the call potentially do. And I can help answer, but it sounds like sounds like you have a handle on this as well.
You probably have a better answer than I do. What I would say is what we found in that work that was published in 2020 is that the state standards for chlorophyll A are just for lakes and reservoirs. And so, right, that's where we're able to see a fairly long, I shouldn't say fairly long, but a decent kind of time series and begin to see that variation. It hasn't been required for a very long time, right? So it's a much thinner record if you're looking at something like chlorophyll A than if you're looking at dissolved oxygen, which is the reason we focused on DO in the Tampa Bay study for exactly the same reason. So we'll have to see, right, once we get into Texas, what we're going to be able to do. It's just the key is observing it in enough places at, kind of over a long enough period of time, because, it tends to change slowly, right? Or maybe you get a spike, but it goes down quickly. And so you're not kind of going up and staying up for a long time. And so trying to estimate those relationships, you really need that kind of variation. And we'll just have to wait and see whether we have enough in, and what's available in Texas to do that.
And to also add to that, in one of our earlier Lunch and Learn workshops featuring Dr. Wetz from Texas A&M Corpus Christi, he actually presented specifically on this topic, and he had a multi-year analysis of changes in chlorophyll A. It was very interesting to see. I believe he may have looked back over 2 or 3 decades.
Great.
And he had some unique and very interesting observations from his analysis. They've also published at least 1, if not 2 report cards looking at chlorophyll A changes from a review period to review period. It changes over time. And that was done through Heart Research Institute at Texas A&M Corpus Christi as well.
That's great.
Amanda writes, can you go over the shares of impairment plots again? I missed how you were breaking down proportion by analyte, but I really like the figure.
Yeah, so let's take a look at that. So this is the figure on the left-hand side here. And what we're trying to figure out, right, is kind of what is the share of non-attainment, right? So each water body, right, in the state that's covered by the Clean Water Act has, right, and it's true for state regulations as well, has designated uses, right? And so we take the kind of most restrictive designated use, which would be, if water was designated as a drinking water, was it like, Lake Travis, drinking water reservoir, but also, for recreation, we would take the drinkability, right? That take the sort of most stringent standard. And then we say, of these 5 water quality parameters that are part of EPA's quote water quality ladder, right, that kind of has values for these, for each of these thresholds of drinkability, swimmability, fishability, and boatability, which one is the constraining parameter? Which one is preventing, right, that water body, if it's not meeting the standard, from meeting the standard? And then we look at how that changes over time. And here what you can see, right, for drinkability, right, the growth in, if you started back in 1970, TSS and DO were not such a big deal, right? It was really mostly about BOD and pH. But over time, right, once you get to the right hand of the graph, the kind of right hand axis in the graph in 2018, that really most of that impairment, that inability to meet that standard of drinkability is coming from dissolved oxygen and total suspended solids. And that's giving us this signal that non-point source pollution is, is a sort of an important source of impairment for that threshold. And you can see that that varies by threshold, right? It's made perhaps less change, or so maybe a little bit less important for fishability, right, than it is for drinkability and swimmability. But it's interesting to us that you can see those patterns. And then, fecal coliform is constraining, but you could just barely see like a little bit of it up here, right? A teensy bit up here. There's not, is not as important and not changing as much over time as the others are.
Great. I wanted to wrap back around to Corey, one of Corey's questions, and she did ask, does Texas routinely collect chlorophyll data for assessments? And the answer is yes. It's done through both our Texas Commission on Environmental Quality Direct, as well as through their managed Clean Rivers program. So there's a group of river authorities, as well as TCEQ staff direct, collecting either monthly or quarterly data, depending on their local plans. But that is routine and goes through the collection process for assessment for meeting its intended uses. So I'm not seeing any additional questions or comments here from the group. So that gives me an opportunity to pause and to thank you, Dr. Sheila Olmstead, for sharing your information and expertise with us. I certainly hope to interact with you more in the future and to understand what you're sharing with us here, and then how to direct that and then engage local communities with helping to improve their understanding as well. I'd also like to take a second out just to introduce our Clean Coast Texas new coastal coordinator, Dr. Christina Lopez, has recently joined Texas State University's team at Meadow Center for Water and the Environment. So we're excited to have you on board. Hi, Christina.
Hi, thanks, Jason.
Yes, ma'am. Would also like to remind folks about the collaborative. This features a set of partnerships with Texas Sea Grant, Texas Community Watershed Partners, and the Meadow Center for Water and the Environment. We've brought together resources and diverse expertise with the idea of having technical capacity and the people on hand to respond to the various water quality and non-point source issues facing local communities. We know that there's not a one-stop shop or one specific recipe. So we want to dig in with you and work with you to learn what your specific issues are and your values, and to figure out if there's an opportunity for Clean Coast Texas to work with you to improve the management of non-point source pollution. Dr. Olmstead, your information has been a missing piece of the puzzle, and I'm not going to pretend to even have digested or really understood everything that you said, but I'm going to go back and watch this. So other folks who are interested, you can also go back. We will have a link posted in the chat box in just a second. I think it may be there. I also want to remind folks that you can go to the YouTube. There's the YouTube channel. Thank you, Allie, for placing the links in there. Thank you, Allie Schlant, for co-hosting today's event with us, and hope everyone has a fantastic day. Thank you so much.
Thank you, Jason.
Yes, ma'am.